So the axis of symmetry we use because quadratic equations we say are symmetric, right? What happens on one side is happening on the other. And the axis of symmetry is that dividing line. Well, normally it would be a straight line, but I can't draw a straight line, right? That divides them in half. And it's that line there. If we were to fold it on that line, both sides would line up, right? And the way we find the axis of symmetry when we're dealing with a quadratic equation is we take that standard form. Say we have ax squared plus bx plus c, right? Equals 0 or equals y. It doesn't matter what we set it up equal to. The formula for the axis of symmetry, or what I call the AOS, is minus b over 2a. And so all you have to do is you don't even really need to look at this, right? You can go, okay, I have, let's say, 2x squared plus 3x minus 4. And I want the axis of symmetry of this equation. I go, okay, well, it's minus b over 2a. And in this, my a equals 2, my b equals 3, and my c equals negative 4. So I just have to plug that in. Minus b, well, that's minus 3 over 2 times a, well, that's 2 times 2. So my axis of symmetry is at negative 3/4, right? That means if I have a graph, normally I would have a better graph than this, but let's say this is 1, right? So my axis of symmetry would be at negative 3/4. So it's just below the 1, right? The negative 1, right? And that is our dividing line. So what if we had minus 2x squared minus 4x plus 3? In this case, my a equals negative 2, my b equals negative 4, and my c equals 3. So when I want to find that axis of symmetry, I've got minus b over 2a. So that's minus, my b is negative 4, so it's minus 4 over 2 times negative 2. And we would have 4 over negative 2, over negative 4, which is just negative 1, right? And that's all we need for the axis of symmetry. But the thing to remember about the axis of symmetry is that the axis of symmetry is the x value of the vertex. The vertex always lies on the axis of symmetry. So it will always be that x value, right? Which means that, say I have negative 1, right? Say we're using this equation right here, right? Minus 2x minus 4x plus 3. And we found that the axis of symmetry is negative 1. So our vertex, what we know is that the x value is negative 1. We don't know what the y value is, right? And so if we want to find the y value of that, all we have to do is plug it in to the original equation, right? So if we have minus 2x squared, that would be minus 2 times negative 1 squared minus 4 times negative 1 plus 3. And whatever comes out of this is the y value for our vertex. So negative 2 times negative 1 squared is just negative 2 times 1. Negative 4 times negative 1 is positive 4 plus 3, right? So we have negative 2 plus 4 plus 3, which equals 5. right? So at negative 1, 5, we would have our vertex. Does that make some sense? Is the negative 3 carried over to the negative 3/4, or does it mean the whole fraction is negative 3/4? I don't know what you're talking about. Is that on this problem? It's negative 3/4 is the fraction. It's where our axis of symmetry lies. Like right here, when we said it was negative 3/4, everything goes along that x value of negative 3/4. It's saying that everything that happens on one side of that happens on the other side of that line. It's just saying it is the dividing point of our parabola, right? And in this case, say we were going at this one's negative 1. Pretend this is a 1 right here. It's saying that everything that happens on this side happens on this side. Both sides are equal from that line. So yeah, it's specifically for when you graph them. Because if I know, like here we've got, let's do it with the one we just did. Ooh, what happened there? You see what I did? I like took that piece and moved it. I didn't even know that was a possibility. Wow. So if I'm graphing this equation right here, this minus 2x squared that we did, and then we've got this right here, right? Let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to do a different color to mark everything up. We know that the axis of symmetry on this is negative 1, right? It's what we found out right here, is that it's negative 1. So right here at negative 1, I have this line that goes down it. I should have just busted out the ruler. But you get that, right? This is at negative 1. We have a point on here. Everything's going to happen on both sides of that negative 1 is what it's saying. So I have a point, I know, at negative 1, 5, right? It's my maximum. Now, if I use the quadratic formula, I can find the other 2 points that hit this x-axis, right? And it allows us to graph the whole thing. So, but all I've found so far is the axis of symmetry, and then I know that the vertex is on the axis of symmetry. So now I can just use the quadratic formula, right? Once I find what this equation is. So we've got our A equals negative 2, our B equals negative 4, and our C equals 3. I need to put it down there so I could see what those numbers were. And now we do the quadratic formula and we'll find those other 2 points, right? You can do it first. It doesn't matter which order you do the quadratic formula in or the vertex. It doesn't matter because you're just finding all those points that you need to make the graph. So for us, it would be x equals minus b. Well, remember that's minus 4 plus or minus 4 squared minus 4 times a, which is negative 2, and c, which is 3. I don't know what this is going to look like because I just made this problem up in my head, over 2 times a, which is negative 2. But it doesn't matter because it'll still graph. It's still quadratic. Just might be an ugly number that I wind up with at the end. Negative 4 squared, that's positive 16. People were making a big mistake where they weren't including the negative into the square, thinking they had a negative underneath that square root. Minus 4 times negative 2, that's positive 8 times 3 is plus 24 over negative 4. Well, that's convenient. That's 4 plus or minus the square root of 40 over negative 4. That breaks down to 4 plus or minus 2 radical 10 over negative 4. And that fraction should be reduced by at least 2, right? It should be 2 plus or minus radical 10 over negative 2, right? And then we'd find out about where these go, right? Based probably on a calculator. One is going to be a little bit on this side, and one is going to be a little bit on this side. And I can tell you that for sure, right? One, because they have to be on this side of this, but I know this one's probably going to fall like kind of like that, right? I don't feel like plugging it into a calculator to see exactly where it falls. But what it does is it gives us where these X values are going to lie, right? A roundabout area of where those X values are going to lie on the X axis. And those are the 3 points that we need to create the graph, right? One is given to us by the axis of symmetry and the vertex, and the other 2 are given to us by the quadratic formula. And those are the only 3 points you need for the graph. And it doesn't matter how accurate it is, because I don't have to write a number in here. I could just say that this one is 4 plus square root of 10 over negative 4. And I can say that this one is, or sorry, it would be over negative 2, right? 2 plus, I'm looking at the wrong spot, comma 0. And I could say that this one is negative 4 minus the square root of 10. Sorry, negative 2 minus the square root of 10 over 2, comma 0. Right? I can just label the point. I don't have to label the graph. I can label the point instead. Right? All you have to show me is that it falls on either side of that axis of symmetry. And have a general idea of whether they're positive or negative, right? Like whether they land in here or in here. Was that helpful? And we finished just in time. My next class doesn't start for a couple of minutes. So I am going to end the recording and I will